All right, y'all. Our last limit station is limits at infinity. So these are limits as they go out towards positive or negative infinity. So as they go out towards positive or negative infinity in the x direction. Okay. So we're going to graph f of x equals 3x squared over x squared plus 1. And this one's weird. So use your calculator. If you're like, Mr. Bone, I don't know what's going on with this. Okay, so we have a horizontal asymptote at 3 because it is and exponents are the same situation. On this one, we go through the origin and then it does this wonky business. It's a weird rational function. But anyways, okay, so let's talk about these limits. So the limit as x approaches 0, what y value does it look like it gets to? Well, it gets to 0. So that one's nice and easy, but also not really what we're talking about with these notes. But I just toss it on there. Make sure you can still figure it out. So let's talk about the limit as x goes towards infinity. Well, as it goes out towards infinity, it approaches up towards the asymptote. From what we really know about vertical asymptotes, it shouldn't cross the vertical asymptote. So all it's going to do is it's going to get closer and closer and closer without ever actually reaching it. But it's going to be so close. Can we basically say it's 3? Yes. So our limit as it goes towards infinity is 3. And as it goes out towards negative infinity in the left direction, it would be the exact same thing. It's approaching that horizontal asymptote. So for our limits as we go towards infinity or negative infinity of rational functions, those limits are always going to be equal to what the horizontal asymptote is. So quick review of our 3 different types. So if the degree of the numerator is less than the degree of the denominator, then the limit of the rational function is... So numerator is less than, so that means it's bigger on the bottom. So the limit of this rational function is 0 because it's bigger on bottom. Horizontal asymptote is y equals 0. If the degree of the numerator is equal to the degree of the denominator, then the limit of the rational function is the leading coefficients divided. Because this is our exponents are the same, divide coefficients. So our horizontal asymptote is those leading coefficients divided. Okay. And then if the degree of the numerator is greater than the degree of the denominator, then the limit of the rational function is infinite. Okay, which means our limit is either infinity or negative infinity, and that we need to continue doing some work, which we talked about in those day 3 notes, to find out which one it is. Because remember, this is our bottom, bigger on top, none, because we have no horizontal asymptote. We have a slant asymptote. Okay, so those are kind of the notes section. I'm going to go through a couple of these example problems with you. Maybe. Yep, there we go. Okay, I'm going to go through a couple of these example problems with you. So let's look at the way these work is, I know it's weird, but we're just working with what we got. This is supposed to be in class. Okay, but each of these problems gets one of these limits and gets one of these limit situations. So EDC, Bobo, or Bottom. Okay, and then one of these different limits like infinity, negative infinity, D and E, values. So let's look at 31. So 31, we have the limit as x approaches infinity of 2x minus 1 over x plus 1. Okay, so I look at those leading terms. It is x over x because they're both to the first. So it is an EDC, which means for my limit, I divide those coefficients. So 2 divided by 1, which means my limit is just 2. Okay, so our limit is 2. Sorry for the awkward pause. I just had like 30 minutes between the first part of this video and the second part of this video. But we're going to jump back in. So let's pick another one that's a little bit different. All right, let's do 32. So the limit as x approaches infinity of 2x plus 5 over 3x squared plus 1. I'm sorry, I was pretty sure that's 32. Yeah. 2x plus 5 over 3x squared plus 1. So once again, we look at the leading terms, exponents. It is 1 over 2, so it is bigger on bottom. So our horizontal asymptote is 0, which means our limit is 0. Nice and easy. Okay, let's look at one of the hard ones. So 36, 2x squared minus 4x over x plus 1. I believe it was as it approaches negative infinity. Yep. Okay, so on this one, we look at those leading term exponents. So squared over 1, so it is bottom. Okay, and I went over this in the notes. So we can do it algebraically, which is kind of a hassle because you got to plug in numbers. Okay, but we can also just do it with our little cheat by looking at two things. We want to look at the leading coefficients and at what infinity we're going to. So our leading coefficients are 2 and 1. So 2 over 1 is a positive slope. So I'm going to make a positive slant asymptote. Okay. Then I look at which infinity I'm going towards. So I'm going towards negative infinity. So I'm going to start on the right, and I'm going to go towards negative infinity. And then when I run into my slant asymptote, I'm going to follow my slant asymptote down towards, in this case, negative infinity. So what is my limit? Negative infinity. Okay. Now, just kind of as some extra explanation, I've gotten questions on this before. So first thing, I got questions on, well, Mr. Arbone, why didn't you go up towards the slant asymptote? Well, if I go up by the vertical line test, that's now no longer a function. So I can't be not a function. So I can't go up and back where I came. I have to continue forward. Okay. The other thing that we know is I can't cross the slant asymptote, so I have to keep going down. And then the bottom of the slant asymptote is negative infinity. The top of the slant asymptote is positive infinity. If this was the opposite, and it was as x approaches positive infinity, I'd go on the same slant, but I'd go left to right, and I'd follow it up towards the top of the slant asymptote. Okay, so when you're doing bottom, you use the leading coefficients to determine the slant of your asymptote, if it's going to be a positive slope or a negative slope. And then you use which infinity you're going towards to know if you're going to go from the right to the left or if you're going to go from the left to the right.